Imagine a dark room lit only by the trembling flame of a furnace. Glass retorts and flasks filled with strange sediments are arranged everywhere, and the air carries the sharp smell of sulfur and mercury. The man hunched over the table is no mad sorcerer from a fairy tale. He might be one of the greatest minds in human history, Isaac Newton perhaps, or Robert Boyle. Today we're used to drawing a clear line between chemistry and alchemy. The first is serious science, the second, superstition. But for nearly 2,000 years, they were one and the same. Alchemy was humanity's attempt to crack the access code to nature itself. The philosophy of transformation. To understand why alchemists spent their lives experimenting with lead, you need to forget the periodic table. In their world, everything was made of four elements: earth, air, fire, and water. But there was a deeper theory too, the theory of sulfur and mercury. Alchemists believed that all metals grew inside the earth, much like plants. Gold was the perfect metal, a fruit that had fully ripened. Lead, by contrast, was a sick or unripened metal. The alchemist's task was not to perform a miracle, but to accelerate nature. The chief instrument for this was to be the philosopher's stone, lapis philosophorum. It was believed to be not merely a rock, but a kind of catalyst substance capable of purifying matter. The second goal was the elixir of life, which would grant eternal youth. Many believed the stone and the elixir were simply two forms of the same substance. Few people know that Isaac Newton, the father of classical physics, wrote more about alchemy than about optics and gravity combined. His alchemical legacy amounts to over 1 million words, which he kept hidden from the public for decades. Why? Because in the 17th century, alchemy was banned by law, and multiplying gold could land you on the gallows. Newton wasn't merely dabbling. He believed that the ancient texts of Hermes Trismegistus contained the encoded laws of the universe. He spent up to 18 hours a day in his laboratory at Cambridge. The experiment with the green lion. One of the most famous processes in Newton's notebooks involves work with the green lion. In alchemical symbolism, this referred to a powerful acid, often nitric acid or a mixture of salts, that devoured metal. Newton believed that by dissolving a metal down to its original state, he could reassemble it into gold. Unfortunately, these experiments left their mark. Analysis of Newton's hair centuries later revealed staggering levels of mercury. His famous nervous breakdowns and bouts of insomnia were most likely the result of chronic poisoning from heavy metal fumes. Strange and dangerous experiments, urine, and the discovery of phosphorus. One of the most curious and consequential stories in alchemy occurred in 1669, involving an alchemist named Hennig Brand. He was obsessed with the idea that gold could be extracted from the human body, since urine has a golden color. Brand collected several hundred liters of urine from soldiers' barracks, according to legend, and boiled it down to a thick syrup, then calcined it with sand. He found no gold, but suddenly something in the flask began to glow in the dark. He had discovered phosphorus. Brand called it cold fire. It was the first time in history that an alchemical search had led to the discovery of a new chemical element. Mercury was the foundation of nearly every alchemical experiment. Alchemists called it mercurius and believed it was the very soul of metals. It was heated, distilled, and mixed with sulfur and arsenic. The danger: mercury vapor destroys the nervous system. Many alchemists ended their lives with trembling hands, fallen teeth, and in states of profound madness, all while believing they were on the verge of achieving immortality. The hunt for dragon's blood. This was the name given to cinnabar, mercury sulfide, because of its vivid red color. Alchemists tried to revive it, believing that the red hue was a sign of vital force capable of transforming lead into gold. Paracelsus and poisonous medicine. Not all alchemists were chasing gold. Philip Aureolus, Theophrastus, Bombastus von Hohenheim, known as Paracelsus, caused a revolution. He declared, "The goal of alchemy is not to make gold, but to prepare medicines." He introduced the use of minerals into medicine. Before him, physicians treated illness primarily with herbs. Paracelsus began using antimony, copper, and mercury itself, which was used to treat syphilis for a long time. His famous saying, "Everything is poison, and nothing is without poison. The dose alone makes a thing not poisonous," remains a foundational principle of toxicology to this day. From the perspective of modern science, alchemists were correct in their central premise. Matter is transformable. They simply didn't know about atomic structure. To turn lead into gold, you need to change the number of protons in the nucleus. Lead has atomic number 82. Gold has 79. That means you need to knock out 3 protons. Alchemists tried to achieve this using the heat of their furnaces, roughly 500 to 1000 degrees Celsius. Physicists of the 20th century actually managed it, using nuclear reactors and particle accelerators. In 1980, at the Lawrence Berkeley National Laboratory, scientists successfully converted a small amount of bismuth, a neighbor of lead, into gold. However, the cost of the process exceeded the value of the gold, produced by a factor of trillions. Alchemy became possible, but lost any commercial sense. The legacy of the great work, alchemy, didn't die. It transformed. Out of its secret laboratories came instruments we still use today: distillation apparatus, flasks, funnels. Alchemists discovered phosphorus, antimony, and arsenic, and learned to produce strong acids and gunpowder. But alchemy's greatest legacy is the idea itself, that the world can be changed, that a human being can take imperfect nature and improve upon it. The next time you hear Isaac Newton described as a strict rationalist, remember his secret notebooks. Remember how the greatest mind in human history stared through long nights into boiling mercury, searching for a spark of divine order. Perhaps it is precisely that audacity, the desire to achieve the impossible, that has made our civilization what it is today.